All right, so this will be the first of two lectures on geology, and we're going to really look at kind of mineral resources. We're not going to do the whole chapter, but there are bits and pieces we definitely want to do. And the first thing I want to talk about is, I just had something land on me here, the real cost of gold. And, you know, we use gold all the time. You know, some of us are wearing gold, you know, we use it for rings, jewelry, and other things, but gold involves massive amounts of digging for little payoff. For example, a pair of wedding rings produce enough waste to equal 3 mid-sized cars. And about 90% of the world's gold mining operations extract gold by spraying a solution of highly toxic cyanide. And so that also builds up and causes pollution issues. And we are one of the top 5 producers of gold. So it's a commodity that we buy and sell, that we use, and we want to think about what is the real cost besides just the price that we put on for buying it on market. So what are minerals? So here's a bunch of a list, and don't, you know, I have to memorize them. I just pulled off the web something that we use. And a mineral is a naturally occurring chemical element that has a certain crystalline solid structure. And so what happens is we have these resources, and these are all non-renewable. And it took, you know, millions of years to form, and as we use them up, they will be gone. So what's a rock? A rock is, you know, you think everybody goes, oh, we know what a rock is. One or more minerals found together. And there's 3 different types of rock types: sedimentary, igneous, and metamorphic. So I would like you to know the 3 differences. So take a look at those. I don't think I'm going to go over them. I think you can read. But they are non-renewable, and that is the key. And so here's some of the ones on the right, 35 minerals that are critical to U.S. national security. And it really comes down to these are going to be a big game in the future. What's going to happen is certain countries have more of these than others. And when we start talking about what we use them for, and some of those may be important for computers, things like that, that who controls the minerals or may have the power. So that is something that we should be well aware of as we go. And so they talk about depletion time, and that number varies. So I'm not really giving you a number, because it determines on how we do it. Do we just use raw minerals and ores? Our depletion time is going to be fairly quick. If we are trying to recycle, then it's going to be a little bit slower. And then if we're recycling, reusing, reducing consumption, and all those things that we talk about, the 5 R's, it'll even be longer. Depletion time is actually calculated as time it'll take to use up 80% of the resources at some particular rate. So I do want you to know that definition, but I can't give you a definition for any one mineral per se, or expect you to know it, because that can change on finding new sources by slowing the usage, things like that. But again, got to remember, they're all non-renewable, and that means eventually we will run out. And crucial importance of rare earth minerals, you know, LCD flat screens, light bulbs, fiber optics, smartphones, and digital cameras. So the computer generation, we're using a ton of this stuff. And China right now is producing 95% of it, which gives them a huge amount of power. And so want to keep that in mind. Market prices affect supply. You know, lower grade ores cost more to pull out of the ground. But you know, depending on the importance of getting them, some countries will increase. Again, but because of subsidies, that throws the free market off and makes it very, very difficult to kind of gauge on what we should do. You know, California has rare minerals. We don't necessarily go after them because of the cost, the environmental cost. again, if they were extremely scarce and they were mandatory for security, I would imagine that all of a sudden we could afford it. And I don't know what that means money wise, maybe, but the environmental impact will be very, very high. So we really need to kind of take an overall look, stop talking just market prices, and maybe, you know, again, the sustainability issue is what makes common sense use. There's some biomining instead of using things like cyanide, where you actually use bacteria. It's a lot slower process, but definitely has a very low impact on what that does to the environment. And can we use more minerals from the ocean? Yes, we could. There are some down there. There's not a ton of them, but you know, we're not quite sure. And it's amazing because in 2011, you know, they're talking about all this stuff, and a lot of people just suggest that these guys, oh yeah, you go down there and you know, all the animals just move. I don't know where they're moving to. And as a biologist, I know that's bullshit, but you know, there are minerals down there, and that's a fact. Again, it's very expensive as we speak, but as they become more and more rare, we may figure out ways of doing that. And again, environmentally, I'm not sure how good that is. All right, so Vogel principle 74, number 3, mismanagement or the destruction of renewable resources can render them non-renewable or non-usable. So even the reusable stuff, you know, we really didn't talk about this, but with forests, it's a renewable resource. You cut down a tree, it'll, you know, and plant another, it'll grow back. But if you plant it back down too quickly and don't sustain it well, it will become non-reusable. So just a thought I wanted you to keep in mind.